Now with IB questions, a lot of times they will give you what I call decontextualized questions to see if you understand how the formulas work without any context. So we have two events, we don't know what they are. We can't even think about them. We know one of the events' probability is 9 out of 20. The other event's probability is 3 out of 10. And it just so happens that the probability of A or B is equal to twice the probability of A and B, but we don't know what either of those numbers are equal to. So given that, what could we do? Well, we've got our addition rule. We know that from our formulas that the probability of A or B is equal to the probability of A plus the probability of B minus minus the probability of A and B. There's our formula for the probability of A or B. That's our addition rule. Now in this, we know probability of A is 9 out of 20. Probability of B is 3 out of 10. I'm just going to make that 6 out of 20, so I have a common denominator already. I don't know the probability of A and B. And I don't know the probability of A or B. But can you see that if you substitute at this point this information that you have right here, instead of writing probability of A or B, what could I write instead? I could write 2 probability of A and B. Basically what we're doing now is we had an equation where there was 2 things that we didn't know. We have another equation that we underlined here in green that's 2 equations that we don't know. And as soon as you have 2 equations with 2 things that you don't know, you can use substitution or elimination, all of those techniques that you learned before in systems of equations. Do you remember that stuff? Where you have one equation that's x plus y equals 5, another equation that's 2x minus 2y equals 1, and you can now figure out where they intersect, or you can figure out what x and y is, either by elimination or substitution. Right here, I use substitution because it was really easy. Instead of writing probability of A or B, I could write 2 probability of A and B. Now, if I rearrange things, add probability of A and B to both sides, I'm going to get 3 probabilities of A and B. And on this side, I'm going to have 15 out of 20. Divide both sides by 3, and you figure out the probability of A and B. Is 5 out of 20. That still hasn't helped us solve any of the questions that we've asked so far, but maybe it's going to get us somewhere. I now know the probability of A and B, so if I want to find the probability of A or B, I could either use our actual formula, right? Because it's going to be 9 out of 20 plus 6 out of 20 minus, and now that I know probability of A and B is 5 out of 20, I'm going to figure out that this is going to be 9 plus 6 is 15 minus 5, 10 out of 20, or 1/2. If you want to write that out, probability of A and B is equal to 9 out of 20 plus 6 out of 20, and now we know A and B is 5 out of 20 to get 10 out of 20. We could have also used this formula here at the top that was given to us. We're told the probability of A or B is equal to 2 times the probability of A and B, so you could just take the 5 out of 20 and times it by 2. Now, probability of A and B, and then this symbol here is the complement. And then we want to find the probability of A and not B. So for parts B and C, thinking about those and not having a formula that those things are in it's starting to tell me maybe if we draw a Venn diagram, that can really help us out here. Do A in blue, B in green. Now, a couple of ways you can do a Venn diagram. Either you can think using the common denominator. We have a common denominator of 20, so we can imagine maybe there was 20 things in total and put our numbers in that way. Well, if there was 20 things in total, we figured out that the probability of A and B was 5 out of 20, which would mean there would be 5 in this section in between. And probability of A was 9 out of 20. That would make this a 4. Probability of B was 6 out of 20, makes our entire circle 1. And sure enough, probability of A or B, which we figured out to be 10 out of 20, those add up to 10. There would be 10 then on the outside that don't fit into anything. If you're unable to see a common denominator, another way you can draw a Venn diagram for this is actually to use the percentages. Wow, when we get 5 out of 20 for the middle part, that's 25%. So we could write 0.25 for that middle section. We know that 9 out of 20 is 45%, so that would make this 20% here. We know that 6 out of 20 is 30%, which would leave us with 0.05% there. And that adds up to 50%, leaving 0.5 or 50% there. So you could also do this Venn diagram with percentages. It somehow seems nicer with the whole numbers, but everything works out to be the same. Now, for part B, we're asked to find the probability of not A and B. Well, anytime you're trying to figure out a complement, it's going to equal everything minus the probability of that. And we knew that the probability of A and B was 5 out of 20. So if we do 1 minus 5 out of 20 and get a common denominator, because 1 is 20 out of 20, we'll have 15 out of 20 for the probability of not A and B. And C was A and not B. Let's look at our first Venn diagram. It needs to be in A, but not in B. Can you see that that is 4? Or if you use your percentage one, can you see that that is 20%? So with the 4, you would have to say it's going to equal 4 out of 20. With the percentage one, you know, that's already given to be 20%. Probably part B would have been okay without a calculator. Part C would have been difficult without drawing not okay without a calculator, okay without the Venn diagrams. Part C would have been difficult without drawing that Venn diagram to see what's happening. Everybody have a chance to try this one once you put it into the formula? You able to see that the only thing you didn't know was the probability of B? And then solving for the probability of B, you got 0.35, so then the probability of not B is what would be left, which would be 0.65. Anyone solve this with a Venn diagram? Putting values into here, you knew the probability of A and B was 0.2. Then the probability of A is 0.55, leaving you with 0.35 here. And since the probability of A or B was 0.7, that would leave you with, this is 0.55, this is 0.15 left in here. So we see that the probability of B is 0.35, so the probability of not B would be 0.65. So there's 0.35 here, 0.35 there, 0.3 on the outside here. Not B would be this 0.35 plus that 0.3, and you could use a Venn diagram to solve for this one as well.